Okay, we have about 3/4 of you guys are done, so I'm going to go on with explaining what our answers are here. And those of you who haven't finished the last couple of them, we'll see them as we go through. So, first one, what are points called that define the intersection of a working line or a fascia beam in the center line of bearing or center line of pier? So we got that right. So, working points, and where, kind of make it a trick question, where are we going to find the working points? On a survey sheet and route to plan. Yeah, they're on many sheets. The sheets, the working points tell us where we are compared to the substructures and the fascia beams or the center line of working. What's the distance from working point D to working point E? So many places we can find that. We can find it on some of the, like abutment sheets. We'd be able to find that. Actually, we're not sure is that both on the abutment, but where's the easiest place to find it?
Bridge layout.
Bridge layout sheet. And let's see that from D to E. D to E is actually along the working line. So it's D is on the center line of south abutment, and E is at the pier. So easiest way to find that one is indeed on the bridge layout sheet. The elevation that a ring must be set to in a cofferdam is found in what document? Is it the shoring or cofferdam drawings prepared by the engineer, or the bridge plans, or foreman or inspector? So indeed it is the contractor's engineer. They produce the shoring plans. It'll show how deep the sheeting goes, what the ring elevation is. And I think like Andy mentioned, there's no rule of thumb how deep that sheeting is. Yeah, we can say, okay, yeah, it's usually, but we need to see what those plans are. The bridge plans will not typically have cofferdams in them. There have been cases where cofferdams are in the bridge plan for unique situations, but by and large, it is as prepared by the contractor's engineer. Couldn't fool anybody on this one. What's the term called when the pile is allowed to rest for a period of time, then struck again to check final capacity? It is the pile rebound. What's the name of the pile driving formula currently used by MnDOT? Again, fool anybody. You guys are pretty astute there. MPF12 formula. The 12 in a steel pile HP 12 by 53 indicates what? The HP means it's an H shape. So right away that takes out the CIP. It's not a CIP. And the way these things work is HP 12. The 12 is the dimension. So if you have an H, it's the distance from flange to flange. So it's 12 inches. So if you have an HP 16 by, I forget what all the numbers are, 16 by 100, say, that would be 16 inches, the dimension from flange to flange. So the 53 indicates pounds per linear foot. So HP 12 by 53 is a very common pile to use it. It's a bread and butter type of an H pile, so that would be 53 pounds per foot, and the 12 inches is the depth of that number. So our question, HP 12, what does that mean? It indeed is the out distance inches from flange to flange. If the inspector requires additional pile driving after substantial refusal, which is defined here, 240 blows per foot, is achieved, who is responsible for damage? It is the department or owner, because we know that from history. If you go beyond 240, you are really working that equipment. I mean, there could be some damage that would happen to either the pile or even the hammer. And so the department or owner is responsible. So be aware of that. Be aware of what substantial refusal is. when you're telling them, keep going, keep going, keep going. False work must be, and select all that apply. First one is designed by contractor. Yes, it does need to be designed by the contractor. Constructor of the same material shown on the false work drawings. Yes, so the contractor's engineer will design it, and we want to make sure that it has the same. Meet the details shown in the bridge plans. No, the bridge plans do not have anything related to false work. That is a means and method. That's something that the contractor has to do. So the center one there is incorrect. And designed by an engineer, I guess I could do enter on this one. Let's see which ones are correct. Designed by an engineer registered in Minnesota, yes. So it does require an engineer and to be checked by an engineer. And then this one, inspected in the field by the false work engineer and certified in writing that it meets that. So yes, that is correct. So on this, 1, 2, 4, and 5 are correct. There are some questions on the exam that are like this. And if you would have selected an incorrect one, you get 0 for the question. So we've tried to minimize some of those, but there still are some of those. But I would just say, as you take the exam, spend an extra little bit of time. Just.
Hey Paul, I got a comment on that. Like, I've talked to a couple other people when taking the prerequisite. There was one. Yeah. I went through that thing like 100 times.
I don't think you're the only one.
I don't remember which one it was, but it was questions like this.
It's horrible.
It was terrible because
It was the piling one. The one I was
you
telling
go
you
back
about.
through.
It was like 11
I wrote
years.
down everything they had written down there, and I still got it wrong. And I'm like, yep. So
I
you
just
just
kept
got
retaking it, so-
retaking it.
I think we all did.
Yeah. It's like-
I got 100% by the time I was done. I answered one, and then I went through the whole thing. It was a horrible test.
That's what I had.
Horrible.
Okay.
I answered one question.
That's a great comment. So I'm gonna send that note to our guys.
I had my engineer sitting there with me, and it was just as bad.
Yeah, so all they'll see is, boy, they won't even see it.
So I need that, if we get 3 of the 4 correct answers, we still get credit for each one. If we don't, so you have to have all the correct answers.
But if you don't get them all,
Okay, so to wrap up on this one, again, we've tried to, because every year, as I said, we look at what the results are, and this year, there was a question that, whatever, 40% of the people got it wrong. To me, that's not a fair question, especially when it's multiple choice like this, but yes, in this case, if you had selected 1, 2, and 5, but you didn't select this one, you get a 0 credit. So we've tried to push them. Can you give 3/4? But actually, let me say this. A couple years ago, there was somebody who landed at a 69% on the test. I did look at and what did they have for these kind of questions, and we were able to give them partial credit, and we're able to pass them. So if you happen to be in that, which hopefully nobody is, but if you're in that, I will look at them. Because I do get all the questions, I can see what everybody answered.
So do we contact you, or do we contact Dexter?
Contact TechCert, but I will,
You'll be looking at them anyway?
I will eventually, but I'll actually probably get the results by, well, whenever everybody finishes. Last year, there was somebody who didn't take the week 1 exam until Friday of week 2. So, I don't know, if somebody wants to do that, fine, you have that time, you have some hands. Okay. What's the maximum out-of-plumb tolerance for the face of concrete columns? I put this in because we do have the bridge construction manual.
Where in the bridge construction manual is the answer to this question?
Forms and falls.
Okay, I looked at it.
Yeah, so, but in 10 feet, you can get a 1/4 inch, and overall, you can get a 1/2 inch. So the maximum out of bump tolerance is 1/2 inch. So just keep that number in mind as you take the exam, it'll be beneficial.
You want to say that again? Just,
Half inch, 1/4, 10 feet, and what was it after that?
It's a 1/4 inch in 10 and a 1/2 in 20, or max, actually max. Okay, which of the following is true for a rebar that has a designation B915E? Select all that are true. First one, bar diameter is 15 millimeters. No, not all of our bars are English measurements, and this second one is correct. It's in 1/8 of an inch, so it's 1 1/8 inch. So it's 9/8 of an inch would be 1 1/8 inch. So that is true. You know that because of that first number in there, number 9. The bar is epoxy coated. We know that because there's an E at the end of the designation. So that we know, and the bar is 915 inches long. No, we don't know from that number, we don't know anything about the length of the bar. We have to look in our bar bending chart to see what that is. So the middle two are,
That's in the spec, right?
as far as
The chart.
the chart for weight or for diameter.
Yeah.
For weight and diameter, yeah, that's all in 2472. It's, there's a table of 2472. It's toward the end of 2472.
552 and 553.
Page 553, yeah. And then the length of bar splices is on 552. If there's nothing in the plan. So the way that bar splices work is if there's something in the plan, that would govern. But if there's not, you would use this table on page 552 to see what it would be. So it's number of bar, based on number of bar diameters. But as far as the weight of the bar and the diameter of the bar, it is shown on page 553 of the table. Concrete slab span bridges, false earth removal should be. Select all that are true. So this is another one just to get us a little bit of practice on that. Be released slowly is correct. Be kept in place till concrete is 72 hours, then removed. So when we think of what the question said, concrete slab span bridges, so we're looking about the slabs. The substructures are often 72 hours, but the superstructure elements are going to be more. They're typically 7 days. So I guess we need more than 72 hours before we can remove. Next one here, incorrect, be kept in place until barriers and overlay is placed. No, once we have strength in our deck and once it's reached the 7 days, they can start removing. And this one is correct to remain in place till cylinders meet strength requirements. So the last concrete cast meets strength requirements in the special division. So we talked about that. If you have a pour that's 12 hours long, it doesn't really matter what the first concrete is doing. You want the latest, the youngest concrete. And this last one, be removed prior to starting any post-tensioning. No, if you do that, our bridge is going to fall down. Post-tensioning, it produces a huge workhorse for the bridges. So it'll still have reinforcement in there, but the post-tensioning adds that compression into the concrete so it can withstand the load. So again, number 1 and 4 on that particular one are correct. So again, just pay attention. Think of what the question is and what the answers are. How many points of support must be provided prior to bolting steel girders under both line assembly and full assembly? So remember, Nick went over line assembly, full assembly. Line can essentially, you don't have to bolt everything together, so that's all going on. So it's 3 supports, but it does include shoring towers. So if you put shoring towers out there, you might have an abutment, a tower, a pier, that's 3 supports. You don't have to get abutment, pier. So this one is incorrect, where you say it's only the support. So it's 3 points of support, but it does include the shoring towers. MnDOT spec book allows these options for controlling bolt tensioning in the field. And there are 2. There are turn of the nut. And so where do we find that? We find in what spec is steel construction? Steel bridge. 2402. So it's going to be somewhere in 2402. So let's just find it. So bolt tensioning on page 396 of the spec. Bolt tensioning, it says use the turn of nut, it's at the very bottom of the page, 396. Use the turn of nut or direct tension indicator method to verify bit tension. So both the first one and the third one are correct. Turn of nut is an older method, but it still works. You know, you snug tight it. So then this one, snug tight to final acceptance. No, you don't finally accept the bolt there, but that's to get it to the point where the turn of nut can snug. And inspector closely observing tightening procedure at 50% more. No, we want to be aware of what they're doing, but that's not an option in the spec. Turn it out and DTIs are field welding on steel H-piling can be performed by persons who, and what do they do? So the first one is certified by AWS D1.1. That is correct. They do need to be certified by AWS D1.1. That is really the only requirement that we have. The rest of these are good, that they have 3 years of experience, they've graduated from a tech welding program, more than 5 years of welding. So, you know, those are all good, but that still doesn't allow you. If you're not certified for that type of weld you're doing, which is in the first column, you know, that would not be adequate. So, AWS D1.1. What's typical primer used for paints? So this one, anybody remember what spec we used for paint? Remember 24 70 something. 78. 2478. And so if we look at 2478, starting on page 573, we have description and then we have definitions. And then we go to materials on page 575, it's zinc-rich paint systems. And it says that is spec 3520, so then we would have to turn to 3520 to actually see what is required. And then 3520, and that spec is on page 923 of the smaller spec. And so then that we'll talk about zinc-rich paint systems and then a zinc-rich primer. So a zinc-rich is the correct answer for that. Epoxy is used as one of the other codes. It's called zinc-rich epoxy paint systems, or what we typically would have. Pre-stressing strands, typically used in our pre-stressed girders, have what ultimate tensile strength? This is a recent change, and it is 300. It used to be 270, but 300 KSI is what we use. So it's very high strength. One of those strands, and there's one in the back, has an ultimate strength of nearly 80,000 pounds. Literally one strand could hold up a full fully loaded semi. So there's a lot of capacity there. The other ones here, 60 KSI is our typical rebar. 40 KSI is some older rebar. We sometimes will see it in sidewalks and things like that, but not in our bridges. 100 KSI, you might see some steel, that's 100 KSI, there's no rebar, but then our post-tensioning, pre-stressing strand, or both post-tensioning but also pre-stressing strand is 300 KSI. Which of the following is true for the type 4 strip seal expansion joints that Mark talked about today? The gland is designed to move 4 inches is correct. That is what the 4 means. There was an incorrect one of there are 4 glands in the device. No, those would actually be, if we had 4 glands in the device, a modular would actually call it a type 12. Each one is 3 inches. 4 glands times 3 would be 12. So that is incorrect. The expansion joint must be on APL. Yes, that is true. Extrusion made of fiberglass. No. Getting on that one. And gland is made of carbon fiber. No, it's a neoprene material that the gland is made. For type 2 special surface finish. So Melissa talked a little bit about this. I talked a little bit about it in one of my presentations. So this one, just the terminology gets us a little confused. It's a type 2, but it is a single component mix. It comes in a bucket or in like a 55-gallon drum. It gets mixed up and agitated and stirred and spray applied. It also, one of the benefits is it can be applied as soon as forms can be removed. So where this came, and Melissa mentioned it today, it started on one of the bridges up on Highway 10 in Anoka for railings and barriers. They're often cast late in the season, and so this is something that enables us to put that on. It's also a cure, it's not just a color. This one is incorrect. A 2-component mix, no, it's a single component. So SSF2, single component. Must be on APL, yes, that is true. And the concrete must cure for 28 days, no, that is incorrect. It can be applied as soon as forms can be removed. The older products had a 28-day cure, but not the SSF. Which of the following are important considerations in designing forms for abutment stems? Select all that. And I'll have you know there's not this many multiple choice questions, but part of what I want to do in this exercise is there's a lot of concepts we go over, and rather than having 50 questions, this gives us a chance to talk about different concepts. So when you design forms, fluid pressure of the concrete, that's a big force on those forms, so that is indeed something that has to be considered. How fast the concrete will be placed. The faster you go, the more pressure is going to be on those forms, so that has to be considered. And how long the span is to the pier, no, that really doesn't matter, because our abutment, by the time we figure anything going to the pier, it's cured out and it's strong, it's ready to go. So that doesn't matter, neither does it matter the type of backfill behind the abutment, because everything has been cured by that time. The forms don't matter. But the location of the through ties, tie rods do matter, and that's all part of what the forming engineer will come up with. And I think this is the last question. Per the table in the spec book, what's the minimum curing period for pier caps? And 72 hours is correct there. So with that, this last one. Any questions anybody has on Mentimeter, on the test to come, anything before we adjourn?
So on the special surface finish 2, in the spec application part, it says the concrete will be at least 24 hours old.
So it doesn't actually have to be power washed.
So your question is, one of them is
28.
20,
Is that what it says in the spec? Not sure what the number one more thing, 9 o'clock again on Monday. So 9 o'clock on Monday, we'll start at an hour later. So everybody have a good weekend, drive safe.